So now, today we are going to see the properties of stationary waves. So yesterday we have seen how that stationary waves are going to be formed. And in that formation of stationary waves, yesterday I have shown you the formation of stationary wave on a string. Right? So on a string, by showing that stationary wave, what I have shown that here is one rigid support, here is the another rigid support, right? And in between that, there is a string. And if you are going to plug that string at the center, due to plugging, there will be a formation of thrust, which will travel towards the rigid support, which will get reflected as a crust. And when crust is incident on the another rigid support, it will be reflected as a thrust. And thus, there will be a formation of stationary wave. So this, what I am calling here, two transfer waves are superimposed on each other. So we will get stationary transverse waves. Similarly, if I am going to consider a pipe which will be closed at one end, and near the open end of this pipe, if I am going to keep a source of sound like your vibrating tuning fork. So if I hold the vibrating tuning fork near the open end of the pipe and one end of the pipe is closed, then this tuning fork as a source of sound will send out one of the waves. And that wave with thrust will be incident at the closed end, and that will be act as a reflected wave, and you will get such type of stationary wave pattern inside the tube, inside the pipe. So here what happens? Two sound waves will get superimposed on each other. Sound waves are nothing but the type of longitudinal wave. So when two longitudinal waves will get superimposed on each other, then inside the pipe, which is closed at one end, we will get a stationary wave pattern. And this is to be called as your stationary longitudinal waves. So along the string, I will get stationary transfer waves, and inside the pipe, I will get it, the stationary longitudinal. Now using this, now I can see the properties. That is properties of stationary waves. Right? Now in that properties of stationary waves, the first property I can say that regarding this transfer wave. When two transfer waves having equal amplitude, equal period, equal frequency, traveling along the same line, but in the opposite direction, will get superimposed on each other. Then we will get a pattern along a string which is stationary, is to be called as your stationary transfer waves. Clear? Similarly, for a pipe whose one end is closed, I am getting that when that one end is closed, here inside the pipe, two longitudinal waves. When that two longitudinal waves will get superimposed on each other. But what is the condition? That two longitudinal waves must have equal, I can say same amplitude, same frequency. They are traveling along the same line and they have the same velocity. But only they are traveling in the opposite direction. Then I will get a pattern which is to be called as your stationary longitudinal wave. Now yesterday also I have given one of the concept, which is nothing but the node point. Node point is what? See here. At this plucking point, I can say plucking point as a C point, and this rigid wall point I am going to call it as A and B. So at the rigid wall and at the plucking point, the displacement, or I can say that the amplitude of vibration is zero. Then that point is to be called as a node. So in case of your transfer wave, what I am going to say that when along a stationary wave pattern, transverse stationary wave pattern, the point where displacement of the particle is zero, that points are called as a node. Why? Second point is nothing but the anti-node point. So what is that anti-node point? When two transfer waves, obeying all these conditions, get superimposed on each other, then they will vibrate with maximum amplitude. Then it is to be called as a amplitude. So this is what displacement amplitude. Because यहाँ पे आपका क्या है displacement maximum, and this is displacement node. Thereafter displacement. Clear? Then, if I talk about this longitudinal transfer wave, so what is their thing? There also I am getting node point and anti-node point. Where I am getting node point? Node point I am getting at the closer end, and at the center I am getting their anti-node. So node and anti-node I am getting here, and at the open end, slightly above, here again I am getting the anti-node. Now in case of longitudinal transfer wave, when the, what I can say that, when amplitude of that longitudinal wave, resultant amplitude of at that particular point is zero, then that point is to be called as your node point. But what happens there? You can get a sound intensity. The sound intensity will become minimum. And at the anti-node point, your displacement is maximum, so the sound we are getting as a maximum. Right? So in case of longitudinal transfer wave, longitudinal stationary wave and transverse stationary wave, in both the cases, we are getting node and antinode. What is the thing only? The node means minimum displacement and antinode means maximum displacement. So that is the first property. What is the second property? Yesterday we have seen. That is, the nodes are located at equidistance. Or I have given 5 important points. In that first point is the distance between two consecutive nodes, or I can say that two successive nodes or antinodes. That distance is always equal to lambda by 2. So distance between two consecutive nodes means, now here in transfer wave, what I can say that at C point I am getting node, at A point I am getting node. So this corresponding distance, this distance is equal to nothing but lambda by. Similarly, next consecutive nodes are what? C and B. So here also the distance is nothing but as your lambda by. Or if I am saying antinode, now see here in transverse longitudinal wave, here is the first antinode, here is the consecutive second antinode. So this distance is nothing but as your lambda by. So this is one of the important ones. Then here I can say the third property. The third property is nothing but distance between. Just now I have said here distance between node and antinode, either node or antinode, which is equal to lambda by 2. Means what I can say that nodes and antinodes are equally placed or equally spaced. Distance between two nodes lambda by 2, antinode is also lambda by 2, means consecutive distance, they are equally spaced. Then fourth one will be, if you are seeing in the diagram, at A point I am getting node. At the center point here, I can say as a B point, I am getting antinode. Again at C point, node. Again at this D point, I am getting antinode. Means what? Node and antinodes are obtained alternately in the stationary wave. Clear? Then, fifth property is, which also yesterday I have discussed, that is one node and one antinode, consecutive. Now here in the diagram you can see, here at A point, node, C point is also node. In between A and C, the distance is lambda by 2. And this AC distance is going to be called as a path length. And at the center of that path length, I am getting the antinode. Means now distance between node and antinode. At A point, node. At D point, antinode. So distance between A and B point, this distance is nothing but your lambda by. So that is nothing but the fifth property. That is distance between node and antinode. This distance is nothing but as your lambda by. So this is also your one of the important property and which can be asked as MCQ question or very short answer. Clear? Then number 6. If we concentrate in this transverse loop here. So in the transverse loop, I can say that at the node your amplitude is minimum. But when the vibration reaches towards antinode, this amplitude of vibration will goes on increasing. Means from node to antinode, amplitude increases. And again from antinode to node, your amplitude will goes on decreasing. Means what we can say that there is a variation of amplitude. Or I can say that amplitude varies in a loop from minimum to maximum, maximum to minimum. So there is a variation of amplitude. Clear? Then I can say that here, if I am considering the particles from the same loop, particles from the same loop means if I am considering here are two particles which are belonging to loop number 1. So their phase is same. Their phase is in between what? 0 to pi. Getting? Suppose I am saying that this is one of the particle and this is the second particle here. So both the particles will lie in the same loop. So their phase will be in between 0 to pi. Sorry, 0 to pi. But if I am considering the particles from the different loop, means if I am considering one particle from the first loop and second particle from the second loop. So I write first, that is if I am considering particles from the same loop, particles from same loop, then their phase is same. Then phase will remain same. But if I am considering the particles from different loop, so your particles from different loop, if I am considering that particles from the different loop, means one particle from the first loop, second particle from the second loop. The first particle phase is 0 to 180 and for second loop the phase angle is from 180 to 360. Means if I am going to change the location of particles from loop to loop, their phase will goes on changing. So particles from the different loop have different phase. vibrate with same period. So the vibration period of an particle in all the loops will remain same. So period will remain same, but particle to particle, if particle changes the loop, loop to loop, the phase angle will go on changing. Clear? Then here the particles are vibrating about the mean position, but they are not moving from one point to another point. Means what? The particle will get localized in one particular loop, and when they are localized, there will be no transfer of energy. So in stationary wave pattern, there is no transfer of energy. Energy will not get transferred from one point to another, because particle will get localized in one particular loop. They will not allow to go anywhere with respect to their loops. So there is no transfer of energy in this stationary waves, and therefore these waves has labeled as a stationary waves, or they are called as a standing wave. So this is the basic difference between progressive wave and stationary wave. That is, in progressive wave, when wave will propagate, there is a transfer of energy. But when stationary wave will form, there will be no transfer of energy. So like that manner, there are number of properties where we can study through this particular one single diagram. So from this single diagram, we can state the number of properties of the stationary waves. So we can just revise all the property once. Progressive wave, properties of stationary waves. First property, how stationary wave is formed. Now, what is the requirement of stationary wave? Stationary wave requires two progressive waves having same amplitude, same frequency, traveling along the same line with same velocity, but only the direction of motion is opposite. And such oppositely directed waves will get superimposed on each other. We will get the stationary waves. That is number one. Number two, or in that only, when stationary wave is formed, some of the points whose displacement of vibration is zero or amplitude is zero, that is to be called as a node point. And some of the points of the particle will vibrate with maximum amplitude, which is to be called as a antinode. Right? So node and antinode, I am not only getting in case of stationary transfer wave, but also we can obtain in case of stationary longitudinal waves. Clear? Then, second important thing is distance between two consecutive nodes or antinodes is always constant, which is equal to lambda by 2. Then, third, if we are seeing the diagram carefully, we can get that node and antinodes are equally spaced. Means I can say that in stationary wave pattern, fourth property, node and antinodes are alternately obtained. Then fifth property, the distance between node and consecutive antinode is nothing but lambda by. Then if I concentrate inside the loop end points are node and center point is antinode. So in the loop, the amplitude varies from minimum to maximum and maximum to means there is a variation of amplitude in the loop. But if I am considering two particles from the same loop, then their phase angle will remain same. But if I am considering the particles from the different loop, then I will get it. The particles from different loop has a different phase angle. Clear? Then I can say that though their phases are same, but the vibration period of all particles in the all loop will remain. And the last one, and which is very important, when particles vibrate and forms a loop, in that loop, the particle will remain localized. They will not move anywhere. So there is no transfer of energy. So when stationary wave will be formed, there will be no transfer of energy. So these are the important properties of your stationary waves. Now, we are already studied in the starting part of this chapter. We have studied that there is a progressive wave is also there, right? So now I can distinguish between progressive wave and at that of an stationary wave. So I can say that already we have studied the properties of stationary wave. So these are all the properties of stationary waves. And now using that property, I can distinguish between progressive wave and stationary wave. What is the first point in progressive wave? In case of progressive wave equation we are knowing. Progressive wave equation is equal to y is equal to a sine in bracket omega t minus xn minus kx, where k is the propagation constant, omega is the angular frequency. Means what I can say that here, that is progressive wave is always propagating with some definite velocity. So it has some definite velocity. But what we are saying that in case of stationary wave, the particles will remain localized in the loop. Means what? There will be no motion of wave. No motion of wave means what? In stationary wave, it is moving with velocity which is equal to v. Then, second property is in progressive wave, the amplitude of that progressive wave will remain same for all the particles. But here in stationary wave, what I am getting that is amplitude will changes. There is a variation of amplitude, or I can say that amplitude changes from node to antinode and antinode to node. Just now yes. So here is the in stationary wave there is a variation of amplitude, while in progressive wave the amplitude will always remains constant. Then in stationary wave all the particles will cross mean position, right? But in progressive wave the particle will vibrate about the mean position. Means it is not necessary that all particles should cross the mean position. So in progressive wave we are knowing that progressive wave will be in this pattern, right? So the particle in the first crust will move in the upper side, trough lower side, means they are not crossing the mean position. But in stationary wave pattern we have a loop. So loop this format. In this loop the particles are vibrating in this manner. Means during vibration every particle is crossing mean position. While in progressive wave the particles are not crossing, all particles are not necessary to be crossing the mean position. Clear? Then the fourth property is when progressive wave is propagating, there is a transfer of energy. And when stationary wave is propagating, there is no transfer of energy. There will be energy is not going to be transferred from one point to another point in case of your stationary waves. Clear? Why? In case of particles in the successive nodes are moving in the same direction and they are in the same phase. But if I am considering the particles from the adjacent loop, so their phase angle will goes on changing. That also just now we have seen. But in case of, I can say as a progressive wave, the phases of the adjacent particles are here. So this is the difference between your stationary wave as well as in the progressive wave. Clear? So now there are two different questions. One question will be nothing but state the properties of stationary waves for 2 marks, or every property is nothing but your very short answer or MCQ question. And the next distinguished question is nothing but distinguish between progressive wave and stationary wave. Clear? Now I am going to switch over to the another topic, which is to be called as pre-vibration and post-vibration. So now, this pre-vibration and post-vibration means what? That we want to clear. So now in pre-vibration, I can say as a pre-vibration. Pre-vibration, the example is nothing but your simple pendulum. So to this simple pendulum, if I apply the force, then this pendulum will start vibrating in the medium. With its frequency, that frequency is to be called as a natural frequency. Clear? So your vibration of simple pendulum is one of the example of your free vibration. Or if I am saying that a string I am going to consider like your guitar string. For guitar string, if I pluck it and just release my finger from that string, so that wire will start vibrating. That type of vibration is to be called as your free vibration. So in the free vibration, the particles will vibrate with natural frequency. That is the first characteristic. Second characteristic is from the example of simple pendulum. If you are setting the pendulum into vibration and just release it, and if you observe the vibrations, what is your observation? As time passes, the amplitude of vibrations will goes on decrease. And finally, pendulum will come to rest. Means what? The characteristic of free vibration is amplitude decreases along with time. And there is a decrement of amplitude as the time of observation will goes on increasing. And finally, the amplitude will become zero. Pendulum will come to stop. Pendulum will come to rest. Right? So this variation of amplitude with respect to time is nothing but the exponential decay graph. That is, if we plot a graph of, here I can say as a amplitude swell versus time, then the nature of graph will be in the form of exponential decrease. So this is one of the characteristics of this free vibration. Now the question is, why that amplitude of vibration decreases? The amplitude of vibration decreases because this pendulum is vibrating in the air medium, and this air medium is offering a certain resistance for the motion of pendulum. Though it is less, but it is offering a certain resistance. And due to that medium resistance, there is a transfer of energy from pendulum to the medium, and therefore the amplitude of vibration decreases. So this type is to be called as your free vibration. Now the second type of vibration, which is to be called as a post vibration. Now here, the famous example of this forced vibration is nothing but, I can call it as a drilling machine. All of you are knowing the drilling machine. That drill is vibrating and then they are going inside the wall and we are getting a hole. So that drilling machine vibration is nothing but the forced vibration. So how drilling machine works? As soon as your current will start flowing, that drill machine start operating and it continuously vibrates. When you will switch off the current, then and then only the drilling machine will come to the destination. Means what? For forced vibration, there is a need of continuous force. There is a need of some constant force. While in free vibration also we require a force, but there is no requirement of continuous force. Just I'll apply the force and I'll leave the pendulum. But while operating the drilling machine, I want always some constant force, which is to be called as a external periodic force. Why it is called periodic? Because magnitude of that force will remain constant. So when external periodic force will act on the drilling machine, then that drilling machine shows you a vibration, and that vibrations are to be called as a force. Second thing, here the body or the particle will vibrate with a frequency. That frequency is nothing but the external periodic frequency. Means every body has its natural frequency of vibration. But when we are applying constant external periodic force, body will not vibrate with natural frequency. Body will vibrate with external periodic frequency. And therefore, the amplitude of vibration is throughout a time, for a longer interval of a time, the amplitude will remain constant. And hence, if I plot a graph of amplitude square versus time, in case of a forced vibration, I will get this type of graph. A straight line which is parallel to time. Because its amplitude will remain constant. Clear? What I said that amplitude will remain constant. I am not saying that. That is body is vibrating with maximum amplitude or minimum amplitude. What I am saying that only, that is when body is vibrating with external periodic force, then amplitude of vibration will remain. Now this magnitude of this amplitude is dependent on external periodic frequency and natural frequency. How? That is, if there is a difference, if I am saying that the difference between, I'll say that frequency N and capital N is for natural frequency. If difference between natural frequency and external periodic frequency, if this difference is low, then amplitude of vibration is also low. But if the difference in the external periodic frequency and natural frequency of the body is high, then the amplitude of vibration is also maximum. Or the amplitude will become high. Got it? And this type of vibrations are to be called as your forced vibration. So again, on this pre-vibration and forced vibration, there is a question. Either write characteristic of forced vibration or pre-vibration, or distinguish between forced vibration and pre-vibration. Clear? Now, in this forced vibration, I am going to discuss one important case. That is a special case of forced vibration. Forced vibration special case is to be called as the physics phenomenon, which is the important phenomenon as a resonance. So resonance is nothing but the forced vibration. But what is the important condition? In resonance, body will vibrate with maximum amplitude when natural frequency of the body is equal to external periodic frequency. So if you are remembering, here I have written these two conditions. That is when difference in external periodic frequency and natural frequency is low, the vibration amplitude is low. If the difference in external periodic frequency and natural frequency is high, the body will vibrate with. But if the difference will become zero, at that time body will vibrate with maximum amplitude. And that phenomenon is to be called as a resonance. So resonance is the forced vibration in which natural frequency of the body is equal to the external periodic frequency, then body will vibrate with maximum amplitude. And that phenomenon is to be called as your resonance. Now what is the example of this resonance? The famous example of this resonance is nothing but the tuning of radio stations. So when you are tuning the radio station button, so at one particular moment only I am getting the clear and louder sound. If my station varies slightly below or above, I am not getting the clear sound. So that is one of the phenomena which is nothing but the resonance. Then second phenomenon of resonance which will come across when you are going to study the next two topics as a sonometer and resonance tube. So in sonometer and resonance tube, you will get the example of resonance. Clear? Might be you have heard in previous year, last year, in Bombay, Andheri, one bridge is collapsed, railway bridge is collapsed. That is what? That is nothing but the disadvantage of resonance. That is, over the railway rule, there is a bridge. So number of persons are walking over that bridge. So that natural frequency of foot vibrations of the people is equal to the natural frequency of that bridge. So both the frequencies become equal. So bridge vibrates with maximum amplitude and that's why it is collapsed. So that is nothing but the disadvantage of resonance. So in that accident, external periodic force is what? The external periodic force is nothing but the vibrations of number of people foots. That frequency get added up. That is equal to the natural frequency of the bridge. So both the frequencies are equal. So bridge vibrates with maximum amplitude and it will get collapsed. So this is one of the disadvantage of your resonance phenomenon. You have also heard that is when army parade is going on. So if you are seeing the marching of that Jawan, they have a perfect marching period. But whenever that Jawans are crossing the bridge, they will get order that break the marching. Why? Because marching frequency will act as an external periodic frequency. If that number of Jawans are doing marching over the bridge, so their external periodic frequency of marching becomes equal to the natural frequency of the bridge, and might be that bridge will get collapsed. Therefore, they will get that order. That is, while crossing the bridge, Jawans should break their marching. So this resonance phenomenon has some of the advantage or some of the disadvantages. Clear? Might be you have one of the concept, that is if you are sitting in the auditorium, that auditorium is provided with number of precautionary noise or sound absorptive system. Why? Because if you are doing clapping, so clapping is nothing but the external periodic frequency. So if the clapping frequency matches with the asbestos sheets which are above the auditorium, so if natural frequency of that asbestos sheets matches with the clapping frequency, then the roof of that auditorium may fall down. That is also one of the example of this disadvantages of. Clear? So today we have seen properties of stationary waves, difference between progressive wave and stationary wave. Then we have seen post vibration, pre vibration, difference between that and the difference. Clear? So if you have any doubt, you can put your doubt on the group.